Hello, my dear students. Okay, so this is a little video on analyzing our data on the possible correlation of COVID infection and disease with regards to population of the nations of the world and population densities. I'm going to show you today a little bit how to use the data, how to analyze the data in Excel and also StatCrunch to get some information, to glean information from the data. Okay, so this is basically data analysis using Excel and using StatCrunch. I have here on the screen a spreadsheet in Excel, which is a master spreadsheet. Let me move this aside for a moment so you can see the title. This is COVID nation correlation full data, okay? And I just put a number in front of it so it is the first file that appears on the list of files that I have in this folder for the Summer Research Institute of 2020. So that's the title of this spreadsheet. Okay, we start with the basics, which is the title of the spreadsheet. It's informative. All titles should be informative so that we recognize it right away. I sent you individual files, this spreadsheet, but limited because I had the title, COVID nation correlation, but then I put, instead of full data, I put your individual first name, which was the data already parsed. Parsed, it means that it is grouped significantly, all right? So you know that for some of you, I sent you looking on population density. I sent you the number of countries that have above 1,000 population density, 1,000 persons per square kilometer, right? Again, let's look at the units for a moment. On population density, which you know how to do a density now of anything. It's number of people per square kilometer. So basically is this number on the population divided by this number of the area in square kilometers gives us the density. So for one of you, I sent you the countries that have a density higher than 1,000 persons per square kilometer. So 1,000 would be in between from Bermuda up, right? So it's a dozen nations have a population density above 1,000 because the 13th country, the Palestinian territories, have 884, which is below 1,000. Also, as we go along, I'll show you other things on Excel, how to manipulate the data. To manipulate the data doesn't mean that we're doing something that's honest. No, we're just using the data, all right, and rearranging it so that it is more informative. That's typically what it means. Manipulating the data is to move the data around so that it is more informative. So for example, ranking or sorting the data. To rank the data, to rank numbers, means to put them in a particular order. It is also known as sorting in the Excel program and in many other programs. And here is the sorting tab, which we'll use in a little bit, all right? You notice that this data is sorted or ranked by population density, so that we have the highest population density on the first nation, which is Monaco. And it has a population density of over 19,000 persons per square kilometers, almost 20,000 people in 1 square kilometer. It's also important as we go along and we look at the data to have our minds on and to be thinking actively and critically. And this number should elicit from us, wow. Okay, this number should elicit from us a wow. In other words, 20,000 people per square kilometer. All right, that's the population density of Monaco. Of course, Monaco. Monaco only has 2 kilometers. So it has about 40,000 people, and in fact, it has 39,000 people total population in 2 kilometers. So when we divide 39,000 into 2, we get about 19,000 and a half, right? You see? So we should have our minds on and be able to go back and forth between qualitative data. Qualitative would be, for example, the name of the country, and quantitative data, which typically are numbers. All right, they can be letters also, but typically they're numbers. All right, so you see, we are ranking population by density from the highest population to the lowest population. All right, so you can see 20,000, then it goes to less than half, the next country, the second most populated country in the world. So we can answer the question right away. What is the most populated country in the world? Monaco, by density, not by absolute numbers, because 20,000 people, we have more than 20,000 people in Dade County, okay? But by density, all right? So it depends if we're talking about absolute numbers, in other words, total number of people in the country, or we're talking about the density itself, which is related to the area, of course, very small area, high density. It's like comparing a high-rise building, like a condominium or a high-rise building, apartment building, to a house, a one-story suburban house, okay? All right, so the ranking is by population density from highest to lowest, and you notice that the next country, country number 2, which is Singapore, is less than half the density, less than half. All right, it's 8,000 people, of course, per square kilometer, but it has over 5 million, close to 6 million people, but it has 700 square kilometers. All right, so a big difference there. Anyway, here is ranked by the population density is ranked by the highest density to the lowest density. So if we scroll down to country number 230, way down here, okay, we see that country 230, which is Antarctica, 0 because no one lives there on a regular basis. Greenland, also very sparse populated. The one that has 1 person per square kilometer is an island. Pitcairn Island has 1 person per square kilometer, okay? All right, so that is the lowest. So this is the ranking. This ranking is not uniform. It's not uniform, all right? It is actually going to obey what is known as a power law. Power law, and I'll show you, this will come out very visibly in a graph. So we're going to do some graphing today, and you'll learn how to do that. So I'm ranking the data first in order to do the graphing, and the graphing will be informative for us. All right, so now this first tab, or this first spreadsheet, right, I have labeled as full data. It's got, by columns, it's got the number of, the name of the nation, the total population of that nation, the area in square kilometers, then the density, which we already calculated, then the number of infected and the number of disease, which you found out, you search for this data on the internet, okay? And then you have your source, infected source next to it, and disease source next to the number in a new column, okay? And then we also calculated percentage of infected and percentage of disease. This was going against the number of infected versus the total population. And if you want to know the background to this analysis here, to this arithmetic, you click on that cell, click on the cell and look at the f of x here, the function, this is called function of x, f of x, which is equal to y. Y, f of x is y, all right? And this is the formula for y, which is equal to, whenever we put an equal sign, let me make this a little bigger so that you may be able to see better. Oh, but the function doesn't grow. Okay, so the equal sign, once we put an equal sign in Excel, in a cell of Excel, then that describe is going to describe a formula. So whatever goes to the right of that equal sign are active values, okay? Active number cells. So we are picking up cell E2 here, see? E2, which is population. Let me go down again because the f of x doesn't, oops. No. I have to click back in the cell here in the f of x line in order to deactivate. Let me see. Let me click out of here. Okay, now this is active. I can make it small again. Yes, I just wanted the labels to show. All right, so clicking in the cell gives us a function. And we see that it is cell E2, which is number of infected, and row 2, which is Monaco, the number of infected of Monaco, and then times, which is the asterisk above number 8, right? You use shift 8 gives you the asterisk, which is equivalent to times to a multiplication, 100, because it's a percentage that we're doing, times 100 to make it a percentage, and then divided by the larger number, which is going to be the total number of population of that country, which is B2, right? 39,000 for Monaco. That gave us a 0.25%. It's not just 0.25, but it's 0.25% because we already multiplied by 100. So that's a percentage. Anyway, that's how we figured out that percentage. All right, now let me see if I can get out of here. Leave it alone. Good. Okay, anyway, I was talking about percentage of infected and percentage of diseased, and we ran some quick stats on this, and we noticed that it was not informative. There was no significant correlation between percentage of infected and population density, all right? And that's because the percentage of infected is already anchored to the number, the total number of population. But if we go back to the absolute number of infected and we run infected versus population density, then we get more information. Also with diseased and population density, we get more information. But most importantly, between infected and diseased, right? Between infected and diseased, we wanted to see if there was a correlation. We noticed that contrasting or analyzing percentage infected versus percentage disease, we did not get a significant correlation there. But if we go with the absolute numbers, we do. That makes sense because these are deceased from COVID. And therefore, the number of infected COVID, this disease used to belong in here into the infected, right? Which is now this person sadly deceased. So these two categories should be, our intuition is that they should be correlated. And in fact, they are strongly correlated, right? All right, then we want to see if there is any relationship between the number of infected and the population density. In other words, how dense, how crowded people are in that country, all right? How crowded are they with the number of infected, considering that this disease transmits by person-to-person contact, right? Close contact, so that 6 feet apart is sufficient to minimize the infection. And also the number of disease to population density to see if there was any relationship there. All right, so we've done those stats and we analyzed it. Now, I want to show you where I got the categories, the parsing, because I mentioned earlier that to parse the data is to group it in a significant way, in a way that is informative. And how did I come up with this breakdown of looking at the densities of the countries that have a density above 1,000? Why is above 1,000 population density significant and not, let's say, 500, all right, or 2,000? And also why at the lower end, 200 was a significant distinction, above or below 200. Why? All right, that is going to come from analyzing the data and analyzing it in a graphical way, because a graphic allows us to represent the numbers in a visual continuum, in a visual spread. All right, and that visual spread allows us to come to some conclusions to it. How is the data behaving? How are the numbers behaving? Is there a direct relationship? Is it totally linear, like one-to-one? Does it have a positive slope or a negative slope? If it has a positive slope, it means that there's a direct relationship. The higher one number, the higher the other number. If it has a negative slope, a downward facing slope, then it's an inverse relationship. The higher one number, the lower the other number, okay? And so forth. So graphs are very informative when we look at them, because it is a visual spread of the data. Instead of numbers, we're actually seeing something visually with our eyes. And we can glean some trends, okay? And that's why the lines, the slopes are called trend lines. All right, so back to this first tab of data. I don't want to be messing up this particular data sheet, because it has essentially all our data and all the math that we've done on it. All right, so I don't want to damage it. And therefore, what I'm going to do is I'm going to duplicate this spreadsheet in a second one. You notice I have, first I labeled the tab, and I'm going to show you how to label the tab in a minute, but I have here full data. These titles should be informative as possible, all right? So that when we look at the title, we know more or less what we're talking about. For example, the title of the whole data set, COVID nation correlation, full data, all right? So my first tab is the full data. Now, let's look at, I already generated a second tab that is called graphs. Okay, now I'm going to generate another tab. I'll go back to this graph in a minute, but I'm going to generate a new tab, a new spreadsheet, which I'm going to call graph experiments or graph trials. I'm going to call it graph trials, all right? So it doesn't conflict with this title here. So it's basically a copy and paste issue. You bring your mouse, and I suggest you have a mouse. You can work with a pad also if you want, but I find it easier to work with a mouse. So put your pointer on top of the tab down here and right-click, and then select move or copy. Select move or copy. And then here you highlight the spreadsheet that you want to duplicate. We're going to duplicate the spreadsheet and then manipulate that duplicate so that we leave the original intact, all right? So you select full data and then create a copy, click on create a copy and okay. And you see right next to it has created the tab, or actually these two are the same. It has put a number 2 on it because I forgot to rename it. Well, we're gonna rename it now. But you see down here, full data with the 2 in parentheses, all right? It's identical to this other one. If you click here, nothing should happen. It looks like the same, it looks identical, full data, but this was the original, this is the original spreadsheet. And this is an exact duplicate of it. You see I'm on the bottom left here. If you click on it, it looks like nothing happened, nothing changed. But in fact, these are 2 separate spreadsheets, okay? Now I'm gonna take this full data 2 and rename it. This is going to be our playground. This is gonna be our playground, basically, this data. So we can experiment with it and change things, and we still keep intact the original data, which is here. All right, so let's go to this full data 2, right click again and rename. Rename, and so I'm just going to rename it, and you see how it highlights it in gray. It highlights it in gray, so you can just type directly on top of it and it will override the old title. So I'm just going to put what I would say. I put it in capital letters so that I can see it easier, more easily, capital letters. So we said graph experiments or graph trials, graph trials, okay? Oops, misspelling. So go with the left arrow where there is a misspelling. Graph trials, and then click outside, and the title is already embedded in the tab. All right. Let me pause for a moment. I'll be right back. Okay, so now we have this spreadsheet with the title Graph Trials, and we have all the columns here, but there are some columns that are in our way. In other words, we're not going to be analyzing right now. For example, the information source. I'm going to eliminate some columns and clean up this working sheet here, the spreadsheet. All right, this playground, I'm trying to clean it up. So for example, column F, the information, the infected source, I don't need that. So sorry, I'm ahead of myself. All right, so I highlight it by bringing the mouse over the letter of the column, click on it and it highlights it. For example, E, I put the mouse on top of the letter and click on it, left click, and it highlights the whole column, right? Okay, so I'm going to do that for F. Click on F, highlight the whole column, then right click. Now that I have it highlighted, right click and delete. Gone. All right. And I'm going to do the same for the deceased source, the source. I don't need that right now for the graphs that I'm going to make. And I don't need the percentage infected or the percentage deceased either. I'm just cleaning up the page here. So I'm going to put my mouse on top of column G and highlight, but then I'm going to scroll over. I'm going to scan over to the right to include the other two columns, right, like that. Just bring your mouse to the right, and while you hold the click down, the left click down, and that highlights the three columns. And so I can delete the three columns together, go to any one of them and right click, and the same little menu appears, delete, gone. All right, so I just got rid of that. It's a cleaner thing. And now I have this data here. It's got nations, population, area, density, infected, and deceased. All right, and it's already ranked by population density. And I wanted to show you how to make a graph then of this density and the beginnings of what I mean by a power law or power distribution. So the easiest way that I find to make a graph, well, first let me show you how I rank this. Okay, so to rank it or to sort it, let's go, no, let's do the graph first. Okay, let's do the graph. So I find it easier to highlight from the bottom up when I just want to select data. Just want to select data, right? Because if I click on top here, then I have selected the entire column down to infinity. So for example, if I scroll down on the data, the highlight goes way beyond the data. You see the data stops here at 0 at 231, which is actually 230 countries because row number 1 is taken up by the titles, right? By titles, and therefore there's no country on row number 1, so that we have 230 countries. All right, so the last country is this here, 0, but you see the highlight continues down into infinity. If you can keep scrolling down, all right? We're down to 800 rows here, and there's no data because that highlight goes all the way down. And I don't want that because I want to make my graph only with data. I don't want all this blank area in my graph, okay? This is not informative down here. There's no data there. So click outside and get rid of that highlight and start from the bottom. You see how I have row 231 down here? This is the last data on the density, right? So left click that and scroll up. Left click and scroll up beyond the row of letters here. You see I hope you can see this white cross. And if you scroll above, it will keep going up. And the higher you bring this, the faster it will go up. All right, until you get to the very top. And then of course you get rid of the label itself. You're still left clicking, you're still holding down the left click, all right? And you bring down, because you have, what you have essentially is the upper margin of that highlight. You have control of that upper margin with the mouse, all right? Gentle. So you bring it to the last or the first data point, the first data point. Don't include the title, just the data point. And let go of the mouse. Finally, let go of the left click. Now we have highlighted all of the data and only the data. All right, you can see from the bottom, right? Slowly here, but don't click in anywhere else, because if you click in, you will lose that highlight. All right, if you click anywhere in the spreadsheet, you will lose the highlight. So if you want to scroll up and down, just use the right hand bar up and down, all right? And you see that all the data and only the data is highlighted. Okay, and now to make a graph, you go to Insert on the tabs on the upper left, next to Home, Insert, and we're going to insert a graph. So click on the tab Insert, and then move your mouse over. You see Charts, all right, Graphs or Charts. We're gonna do a chart, and it's this one in the middle. It is a insert chart, all right, or it's a line chart. You can also use this one, line charts, all right. Let's look at line charts. So click on the menu of line charts, and it gives you a pull-down menu here. And you can already see, you can experiment and see what kind of graph do you want, what kind of chart, just by mousing above the little icon. So for example, I'm on the 2D line, 2-dimension line, which is 2 dimensions, right? And we have, essentially, we're doing a ranking. So if you mouse over that graph, underneath here, it appears. Give it a second, there it is. You see the graph underneath. On the x-axis is the actual ranking from number 1 down, okay, to the right, the ranking. So the highest, the number 1, the highest population density, to the lowest population density, down to 230, all right? Well, the zeros are not in there, that's why it has 226. At any rate, that's the x-axis, which is the independent axis, is the ranking. And then what is dependent on the ranking is the actual density, the highest density. So it's, we said it was 19,000, it's just below 20,000. You can see that on the y-axis is 20,000, all right? So that one is good enough, it's informative. So you click in it and let it go, and there is the chart. There is a chart, and then you can manipulate it a little bit. When you click into the chart, is active, and then on these bubbles, you can pull on the bubbles and make it a little bigger. So on the bottom right, for example, you can pull down. Okay, you can also make it stretch. Whoops, sorry. Back to, whoops. No, I stretched the wrong way. Let me go back and erase this. Delete. I lost a highlight. Okay, well, I just showed you briefly how to make that chart or graph. I'll go back to it, but I want to show you now how to rank, because this is really the first step to sort our data or to rank our data informatively. And typically we want to go from the highest value to the lowest value, okay? From the highest number to the lowest number. So density is already ranked, but I'm going to do now area and show you the difference when it's not ranked and when it is ranked, right? Let's say that we want to rank the graph by area, Well, I'll show you if we don't rank, if we don't sort the data, it's not informative. So again, we go back to the bottom number, to the lowest number, and left click in it, and then left click again and hold the number, hold the left click and scroll up, keep scrolling up all the way until all the data is highlighted, okay? And then come down to include only the numbers and not the title. All right, now I have highlighted the area, right? And you see that the area is not ranked. The area is not ranked because we have values 2 square kilometers and then 700 and then 1,000 and then 115 and then back to 6. So this data is not ranked. Let's see how that graph looks. Go back to insert here and line plot. Okay, the first one. See how the data looks. You can spread it out a little bit. Okay, so this graph is not really informative because it's just ranking. Number one has a 2 square kilometer density. All right, it's anchored. That's cell number 1 here, and so on and so forth. In fact, these are bigger numbers down here, but there's no really significant trend here. Now, if I rank this data, so keep in mind this chart, all right? And now what I'm going to do is I'm going to click outside. I'm going to select the data again on area, going down to the bottom, and I'm going to sort it or rank it. And you'll see that the graph will be much more informative. All right, so again, I go to the bottom cell, click in it, hold the left click, scroll all the way up, exclude the title. Now I have all my data selected. Now I'm going to sort it or rank it according to size. So you see where I have the cursor here, the arrow is on the home tab. It's on the home tab all the way to the right, okay, where it says sort and filter. Click into sort and filter and a little drop-down menu. You want sort from largest to smallest, okay? Sort from largest to smallest will be the largest number. Typically when we sort letters, we sort from smallest to largest, which will be A to Z. But when we sort numbers, we sort from largest to smallest, meaning largest meaning the largest number, okay? And so that's the sort that we want to do. Click it and let it go. Then this little window opens up, this little window. It is asking you to expand the selection or not expand the selection. In other words, expand the selection means that as we rank or sort this column of the area, if it's going to stay, to expand the selection means to keep the row intact. In other words, let's say here, Antarctica. Antarctica has 14 million square kilometers, right? 14 million. All right. When I sort it, this is going to be one of the highest values. It's going to go way up on top because it's one of the highest values of area, square kilometers. But I want it to be anchored to Antarctica. In other words, I don't want to sort this column by itself. I want the columns, each item of the column, I want it to be anchored to the other information on the row because it all belongs to Antarctica. In other words, I want that 14 million square kilometers to be anchored to 1,000 people, which is the number of population, right? The first column here in numbers is the number of people is 1,000. We know that these 1,000 come and go. In the particular example of Antarctica, these are mostly scientists, pretty much exclusively scientists that go to Antarctica, but they don't live there, they go back and forth. Okay, and certainly I want the 14 million square kilometers to be anchored to Antarctica because it belongs, that's the square kilometers for this nation, in this particular case, is a continent, all right? I don't want it to shift into another. I don't want, in other words, I don't want the columns to be independent. I want them to be dependent of each other so that the information for each row maintains its integrity. We can make the same case for example, here, Pitcairn Islands. Pitcairn Islands only has 47 square kilometers, all right? So I want this 47 kilometers, when it ranks, when it sorts in its proper place, I want it to be anchored to the 50 people who live in the Pitcairn Islands. So I want the whole row, all right, to be anchored to the number that has been selected. And so that is what it means by expand the selection. Expand the selection horizontally is what it means. All right. If we click on the other here, it says continue with the current selection. This means that the selection will not be expanded. In other words, that these numbers will be ranked independently, and this will create chaos in this particular case, depending on the data that we're analyzing. But in this particular case, it will create chaos because now this 14 million will no longer be anchored to Antarctica. In other words, Antarctica will stay down here and the 14 million will go up in the ranking to one of the highest numbers. And Pitcairn Islands is probably going to move very far down here. Well, it's toward the bottom, but it will no longer be associated. The 47 will no longer be associated with the Pitcairn Islands, okay? And that's when we need to do a ranking independently. Each column, rank them independently from the others. In our particular case, no, because the data is associated, all right? The data is associated, they're not independent columns. All right, so we do want to expand the selection, all right? And even though this is a little scary, it seems like scary to sort these numbers, and they're going to be anchored to their whole row horizontally. It sounds scary to the mind, but the computer can do it. So just take a deep breath and hit sort, and you'll see what happens. All right, bingo. So now we can stay down here for the moment. And you see, now we have the lowest country in area is 0.4896. We can round this up to 0.5, half a square kilometer. Half a square kilometer is Vatican City. So you see Vatican City state came all the way down here. Let me give you an example. Let's go back to full data for a moment and look at Vatican City. These are ranked, they're ranked by population density. Well, we can just take so the population density of Vatican City is pretty high, 1,600 people, okay? So we can look at this number, and you'll see here on full data, because this is ranked by population density, we can go to 1,600, here it is, 1,600. See, half a square kilometer, and it is Vatican City. So in the full data sheet, it is one of the 12 countries, one of the top 12 countries of high density, Vatican City, right? It's now a country number 8 here, right? Remember, the one is taken up by the titles. So country number 8 of highest density. But now when we rank by density, because, not density, sorry, by square kilometers, it only has half a square kilometer. So it's the lowest territory, the smallest nation in the world, all right? Half a square kilometer is the Vatican City state. It's a whole nation, and it is only half a kilometer in the surface, a square kilometer. So you see how it anchored, it kept the number, and it kept the nation anchored to the square kilometer, to whatever we ranked. Here's Pitcairn Islands, again, 47, stay with Pitcairn Islands, all right? We were looking at the example of what was down there originally. The bottom one was the full data. Oh yes, Antarctica, right? It was Antarctica, so let's go back to trials here. It was 14 million, so here we could look for 14 million. Okay, here's 14 million, we go across, oops, it's Timor. Where is Antarctica? Oh, 14 million, I'm sorry. Let's go further up. Okay, here, 14 million, look at that, it's number 2. It's the second largest country, or actually continent in the world, all right? 14 million, here is Antarctica. You see how it stayed anchored, right? And all the other numbers also. So the 1,000 population and 0 density, because these are only seasonal, they're not full year round. The largest country in the world by area is Russia, has 16 million, over 16 million square kilometers, and it actually expands about 12 time zones. So it covers half of the world horizontally, Russia. Okay, so that's the ranking. Now, automatically generated the chart, look at that, okay, because it's highlighted. So this chart belongs to this ranking by area. Remember how we had done a chart of the area before, but they were not ranked, and it was all scraggly, going up and down, not informative. Now, when we rank the data or sort the data from highest number to lowest number, look at that. Look at this graph, how informative it is. There's definitely a pattern here, okay? There's a pattern of very high surface, and then drops fast, dramatically, by number of countries, and then it tapers off, long tail to the right, okay? What does this tell us? This tells us that most countries of the world have smaller areas, and a few countries of the world, about a dozen of them, have very high area, surface. You see, so this graph has become informative for us, that most of the land mass of the world is distributed by a few countries. Whether that's ethical or not, I don't know. That's a historical thing. You know how nations develop over centuries and millennia and wars and all that. But the point is that right now, the 230 countries of the world, most of the area of the world belongs to very few countries. And the rest of the countries are down here on this very long tail with smaller and smaller territory, okay? This is actually known as a power distribution. It follows what is known as power law. It's a power distribution. Many things in nature have a power distribution. For example, you look at the number of lions compared to the number of zebras, right? It is the lions that feed on the zebra and not the zebra on the lion. So you're gonna have fewer lions and many more zebras. The same zebras with grass. All right, the zebra feed on the grass and not the grass on the zebra. So you're gonna have much more grass than zebra. And these power distributions are typical in nature, all right, in many, many examples. And they're also typical in population. So we can do the same graph for the population. Let's expand this a little bit so all the numbers are shown. All right, you notice that we ranked for area, and we did not rank for population, but the population of each country stayed anchored to that area, right? And of course, if we rank for area, then we lost the ranking on population density, because density was also anchored to the area, and therefore we lose the ranking on the density, right? And also the infected and disease. So we can rank for any column whatsoever. You can continue to experiment and play with this. Now you can do it more quickly. Let's say that we want to look at population, the ranking of population. First, we can look at the graph without ranking, right? Because now the data is ranked for area. So let's look at so we know that population is not ranked. Look at the numbers are random, back and forth, okay? So let's highlight this and quickly look at the graph of population without ranking. So you'll see the same effect. So there it is, and then simply go to insert, line plot, bingo, the first one, look. Okay, we get this kind of plot. That's the kind of plot we get, and look at this. So it goes up and down, and it's not very informative. There's some kind of trend here, but it's not very visible. There's so much scraggly going up and down, up and down. Keep in mind this chart for a moment, and now let's re-rank by sorting. So I have the population column highlighted. I'm just going to go back to the Home tab, up left, Home tab, and I need to highlight here. It's grayed out, so I'm probably going to lose the sorting. Let me erase that graph. Yeah, I lost the sorting. I have to go back down again. That's why I say the mouse is useful here. Okay, from the bottom up, I'm now going to rank the population, the graph we just looked at. Insert, line graph, first one. Oh, sorry, no, I'm not doing the line graph now. Sorry, go back to Home. Let's get rid of this graph. Okay, I still have highlighted the population here. Now I'm going to sort from largest to smallest. Expand the selection, yes. Okay, there it is. And I still highlighted, you see I still highlighted. As long as I don't click anywhere else in the spreadsheet, it's still highlighted. So directly I can go from there to insert graph, line graph, first one, bingo. Look at that. Look at this graph, how much more informative it is. On population, the same. Basically, what do we get? We get a power distribution. All right, we get a power distribution just like area and just like density. All of these graphs are power distribution. They're not simply linear. They're not just straight lines, and they don't have a trend up or down. It's called a power distribution. So power distribution essentially means, you can look it up online, it means that the dependent variable is varying exponentially to the independent variable. The independent variable here essentially is the ranking number. First, most dense or largest population, what's the ranking here? The ranking here is the most populated country to the least populated country, right? That's the ranking. So what this is doing, just trying to bring this graph up to the highest values here. There we go. Okay, China with 1.5 billion people, then India following closely, almost 1.4 billion people, right? So these are the two highest countries here by population. Then we're the third country with population, 331 million. Okay. And so this means that the power distribution means that on the ranking, the highest values will be raised exponentially, all right, to a power law. They follow a power law. In other words, the dependent variable, which in this case is population, is raised to a particular power or to an exponent. So that y is going to be x to a power, x to the second power, to the third power, to the fourth power, to the n power, right? So it's an exponent. It's a type of exponential, but it's called power law or power distribution. All right, and it's very typical in nature when we have when we do rankings of plants, animals, many things. Okay, so this power distribution is informative because the cutoff here, where the long tail begins, let's say, is no longer growing significantly exponential, right? It's not curved, but it's more linear. It's more linear. So the lower numbers on the graph, on the power graph, are indicating a more linear relationship. Linear meaning one-to-one relationship. a simple linear relationship. And then at some critical point, that linear relationship starts becoming exponential, right? So we can say that these countries down here, these nations, the populations, respond to y equal x to the first power, meaning that as x increases, y increases, or vice versa, right? But just in a simple one-to-one relationship. At some point, the power starts increasing to the second power, to the third power, to the fourth power, to the nth power. You follow? And so it is informative, it is significant when that shift happens from x to the first power, which is basically x, right? To x to the second power, which is x squared, or x to the third power, which is x cubed. When that shift, when that transition happens, is significant because the data is behaving in a different way up here than down here. Okay, so there are two kinds of behaviors, if you will. There's a linear behavior of the data down here, and there's an exponential behavior of the data over here. All right, but it's not simple exponential, it's a growing exponential. X to the second power, x to the third power, x to the fourth power, x to the n power. You see, increasing the power, the exponent, and that's why it's called power law. But these are basically x to the 1, or rather x to the minus 1, because it is, you can see it's a negative slope, right? It's decreasing. What I'm trying to say here is that these data points are behaving differently than these data points on the left. The data on the left is behaving differently than the data on the right. And it's informative to know when that break happens, when the transition happens, at what number does that transition happen. Also, another thing to notice is that typically in the power laws, you have few items on the left, few items responding exponentially, and most of the data points are responding to a simple relationship, a one-to-one relationship on the tail. And that's why the tail is very, very long. See? So most of the data is responding to a linear relationship, but a few points on the data, the highest points, are responding exponentially. All right? So it's not an even distribution. It's not half and half or anything like that. It's loaded. It's loaded on the top at the exponential level. So that's informative. And that's how I determine those categories of the top 12 countries, all right? The 12 countries of the world by density. So let's go back to full data for a moment and look at, since this is ranked by density, the top 12 countries from Bermuda up, or actually, from Bermuda up, we have 1,000, more than 1,000 population density, right? It's only 12 countries. And then that means that most of the countries of the world, more than 200 countries of the world, have a population density of less than 1,000. This begins to be one part of that tail, all right? The long tail. But then there's another significant break above and below 200, because we see that above or below 200, that is still above 200 density, it's only 70 countries out of the 230, so 7 times 3 is 21, right? So it means that one-third of the countries is above population density of 200, but 2/3 of the countries of the world, 2/3 of the countries of the world are below a population density of 100, okay, of 200, I'm sorry. So that's another significant break there. And we see those in the graphs. So now I want to go to this graph spreadsheet that I have here. I had generated this earlier. This is when I was playing with the data, all right? And I have the graphs made already and formatted a little bit. I can show you later how to do the formatting like this with the different colors and thickness. But for now, let's look at the data itself. So when you click on the graph, it highlights behind it the thing that was plotted, the thing that is being plotted on this graph. So you here see on this first graph that I have, and I labeled it significantly, full density distribution, all right? So I click on the graph and it highlights the column that of the data that makes up the graph. So this is population density, right? And you can see that it's ranked. We'll move it out of the way. You see how it's ranked. Here's the 19,000 that we talked about, Monaco. If we move the bar over a little bit, so we show the nations and close in a little bit. All right. See Monaco, 19,000, etc. Let me bring it back up here. Let's go back to density. Oops, something happened. Did I move away from density? Oh yes, I lost the. Okay, let me go back here for a moment and redo this because it's flipped. Let me try something because I think I moved this around. Yeah. See if I can put it down here. Yeah, okay. There. Trying to regain my data. There it is. Okay. So here is population density, right? And it is the full density. Here's the graph. And you can see that it is describing definitely a power law. So that's what I first saw. When I was just fooling around with it to see what kind of graphs it would represent. The ranked population density gave me a power distribution. And so that was very informative to me. And then I started looking for the breakpoint here, all right, by developing other graphs. And that's what I did here. For example, this one is above 200. I still get the power law, right? Above density of 200. Those are the 70 countries that I told you about. Okay, 70 countries. It still has a power law, but the tail is still a long tail. So what I discovered first is that below 200, it is a rather linear relationship. And there it is. So the red is the data. And then the black line is a trend line, as you see here. Okay, the black line is a trend line, which I'll show you how to make a little later. But basically, it is describing the lower end of that tail of the population density here. Right, the lower end of this population density at 200 or less, it is basically a linear. It is the best fit of this graph, of this plot of the red line. The best fit is a straight line, which is a downward slope, which means an inverse relationship or a negative relationship, meaning that the lower the ranking, then the lower the population density. Okay. And so that was informative. And that's why I made a cutoff between 200 density, above 200 or below 200. And that becomes one set of data because this density is behaving in a linear fashion. And then later we're going to plot number of infected versus density and number of disease versus density at different parsing. This is what I mean by parsing. So this is parsing the data. One parse or one grouping is going to be below 200 density, which the other group, the converse group or the complementary group is going to be above 200, right? So above 200 is the other one, has a different type of behavior. It has a power behavior. But then I wanted to get closer to this area of where the power starts increasing faster, all right? And that's where I got the 1,000. So I went and did the other plot. Here it is. Here's above or below 1,000. And I started by doing 5,000 first, right? So first the full graph gave me a power law. Then I did 5,000 and it still is a power law, as you can see here. It's a power distribution, but more shallow, all right? The hump is not as steep, it's more shallow elbow. Then I did 200 and I noticed the trend. So you notice at 200, the trend is that the elbow is even more shallow. I'm sorry, below 2,000. So this is 5,000. It's a little more shallow than the full data. At 2,000, you can see that the elbow is even more shallow, right? Less pronounced. And then I went to 1,000. And what happens? I start to lose the elbow. It starts getting more and more shallow, okay? So this may be a simple exponential already, maybe to x square or x cube, all right? But I'm losing the exponential. So it's moving toward a linear. And that's why at this point, I decided to use 1,000 as a breaking point or as a shift between the exponential and the linear. Because this one, about half of the graph is exponential, more or less. And then the other half is already linear, okay? So it's just by eye, it's just an estimate, but I chose the upper limit of that power graph to be 1,000. So what I consider significant then with regards to the data is to look, one would be to compare the full graph, the full density, all the way, this one. Give me a minute. All right. First, to compare full density, which has a very power law of distribution. And then the upper limit is going to be above or below 1,000. And then the lower limit is going to be above or below 200. You follow? And those are the 5 categories. And then I sent each one of you the data already parsed, so that each one of you is dealing with that. But I'm also going to send you this one, this PowerPoint. Sorry, I'm going to send you this data set, the spreadsheet, which has the full data, because you can play with it like that and do different distributions and see how it behaves, how the data is behaving. This is on population. If we were to do graphs on area or population itself, we will get similar graphs, all right? Starting with a steep power, and then if we start parsing the data in significant areas, we will be moving toward a linear relationship, all right? And those breakpoints are significant. We can establish an upper limit and a lower limit, and we can do the same for each one of these categories, for population, for area, just like we did for density. All right, we're going to stick with density and then contrast, and that's the StatCrunch that you did. You compare density to infected and density to deceased for each one of the parsings, or the 5 parsings that I gave you, because you're 5 students, okay? So each student has a particular parsing. All right, let me stop the video here, otherwise it's gonna get too long, and then I'll continue with a follow-up video on the StatCrunch analysis. So I'm gonna stop now the video and make a YouTube and send it to you. Thank you, bye-bye.